Third example. So for this one, we've got a woman sitting in a bosun's chair. And a bosun's chair is a certain thing designed to help it make it easier for you to lift yourself up. It's used in sailing and it's used in window washing, things like this. It's hanging from a mastless rope that runs over a massless, frictionless pulley. The chair and the woman have a combined mass of 75 kilograms. So their mass is equal to 75 kilograms. With what force does she need to pull on the rope to have a constant velocity, to have a constant velocity? With what force does she need to pull to have an acceleration of 1 meter per second per second? So let's think about what happens when she pulls. She pulls down with some force, and that's the force that's going to become the tension. So she pulls down with some T, right? She pulls down, so there's now this force that's translated into the rope. So we've got this pull coming along, and it's going to pull up here with a force of T. But we haven't paid attention to Newton's third law. If you yank on something, if you're trying to climb a rope, you pull on the rope, you put a tension into it, which causes you to rise because the amount of tension that you put into the rope is the amount of force that's going to be resultant in you going the opposite direction. So the resultant force from her pull is going to be T. So what's the total force that the woman's going to experience from the pull? She's going to experience 2T going up. What other forces are on her? Her weight, m times g. So her weight is m times g, and she's got 2t going. So if she wants to have a constant velocity, we need the sum of the forces equals mass times acceleration. If we want constant velocity, then that's going to be equal to 0. So the sum of the forces is 2t going up, and we'll make up the positive direction. So 2t minus mg, and if it's no change in velocity, constant velocity, no acceleration, this is all going to equal 0. So we've got 2t equals mg. Now we just start plugging things in. So we get t equals m 75 times 9.8 divided by 2. We solve this out and we get the tension that she needs to put into the rope is equal to 367.5 newtons. What if she wants to have an acceleration of 1 meter per second? Very similar. 2t minus mg is going to equal, now her acceleration isn't 0, her acceleration is 1, so the mass times 1, so m times 1. So t equals mg plus m over 2. We plug everything in that we know. T equals 75 times 9.8 plus 75 all over 2. We plug that into a calculator, and what number do we get out? We get 405 newtons. So notice, she's able to do this at a very different rate. She's able to put way less force into pulling herself up using the bosun's chair because she's taking advantage of Newton's third law. She knows that by putting a tension into the rope, she's going to get lifted by that tension doubly, by the resultant force from pulling, just as the tension put into the rope will wind up pulling her up, but so will the resultant force. So she's making Newton's third law work for her. It's helping her out in this case. So she's able to pull with considerably less than her weight is. If she's going at a constant velocity, she only has to pull at half her weight. So that's a really clever way to be able to use less effort on our part to be able to go up. We're able to take advantage of the way that physics works. All right, that's the end for Newton's third law. Hope this made sense, and hope you came away with a lot more understanding. Thanks for watching. Bye.